Welcome, you curious minds, to another deep dive. Today, we're tackling a genuinely fascinating frontier in artificial intelligence.
Oh, yeah. What do we got?
It's about how we make AI agents truly smart, not just with what they know, but how they find information online.
Search. Right. It's harder than it looks.
It really is. We're diving into a groundbreaking paper. It's called Beyond 10 Turns, Unlocking Long-Horizon Agentic Search with Large-Scale Asynchronous RL, and it introduces this open-source project, ASearcher.
Right, ASearcher. I've looked at that. It's a compelling look at how complex, real-world questions demand this whole new level of, well, they call it search intelligence from AI.
Search intelligence, okay.
So our mission today really is to unpack the core challenges that current LLM-based agents, the ones designed to act and reason, not just chat still face.
And
then reveal how ASearcher offers a scalable, efficient, and actually remarkably intelligent solution for navigating all that external knowledge out there on the web.
Okay, so if you've ever wondered why even really advanced AI sometimes struggles with what seems like a simple search.
Or gives you an answer that feels a bit off, maybe.
Yeah, exactly that. Or just incomplete. Get ready. We're about to explore the critical breakthroughs in making AI agents true search experts, teaching them to behave more like a seasoned researcher.
Not just a simple lookup tool.
Right.
So let's start by defining what we actually mean by search intelligence.
Good idea.
It's so much more than just typing a query into a search bar. For an AI, it's this sophisticated ability to, first, interpret and resolve ambiguous questions.
Questions that aren't perfectly clear.
Right. Then, generate precise, targeted searches. Then critically analyze the results it gets back. And then conduct a truly thorough, multi-step exploration to arrive at a well-reasoned answer.
So it's the difference between just looking something up and actually researching it.
That's a great way to put it. Researching versus just looking up.
Okay, so think about a question that sounds straightforward. Like, as of December 31st, 2024, what were the numbers of gold, silver, and bronze medals won by China in the 2012 London Olympics?
Seems easy enough. Should be a quick lookup.
You'd think, but the paper highlights just how messy real-world data can be. Online, you might find conflicting answers.
Maybe an old report or something that hasn't been updated.
Right, so an intelligent agent needs to navigate all that noise, identify the root cause of any discrepancies, like maybe a doping disqualification came out years later in an official report, changing the medal count.
Ah, right. Those things happen.
And ultimately determine the single correct updated answer. This is where existing open source LLM agents often just fall short, dramatically short sometimes.
I might just grab the first thing they see.
Yeah, even if it's outdated or incomplete, not much critical analysis there.
Okay. And current approaches face two really critical obstacles when they try to achieve this expert-level search intelligence using online reinforcement learning, or RL.
Okay, RL. That's the training method where the AI learns by doing, trial and error.
Sort of, yeah. It interacts with its environment, in this case, the internet, and learns from the outcomes, getting rewards for good actions, just like how it might learn a new skill.
Got it. So what are the obstacles for RL in search?
Well, the first major hurdle is the issue of insufficient search turns.
Turns, like interactions.
Yeah, interactions with its tools, like a search engine. Many online RL training methods limit agents to a very small number of these turns, often 10 or fewer per problem-solving attempt. They call that attempt a trajectory.
Only 10 interactions. That doesn't sound like much for a complex question.
It's not. Complex real-world questions like our Olympics example or anything needing cross-referencing, they demand multi-turn tool calls. The AI needs to go out, use its tools multiple times, gather different pieces, put them together.
And these strict limits just stop that.
They fundamentally prevent that deep, multi-step reasoning. It's like asking a detective to solve a complex case, but only letting them make, say, 10 phone calls.
So the AI basically runs out of runway too quickly. It can't follow a lead if it hits that limit. That sounds like a big architectural problem.
It really is. And the second obstacle is a lack of large-scale, high-quality question-answer pairs for training.
The training data itself.
Right. Think about it. To teach an AI to be a world-class researcher, you need loads of examples, millions maybe, complex questions, and their thoroughly researched, validated answers.
And the current data isn't good enough.
Well, existing open-source datasets are often outdated, or they're too simple or just too small. They don't stimulate the kind of complex, multi-step search behaviors needed for really robust RL training.
Like Trying to train an Olympic athlete with only basic exercises.
That's a good analogy. They'll never develop those nuanced, high-level skills.
Okay, so we've got these two massive hurdles. The AI's limited interaction turns, its short attention span, if you will, and the lack of truly challenging, up-to-date training material. So how does ASearcher, this project, start to tackle something so fundamental? How does it make its AI agents more patient, more persistent, and give them the complex data they need?
Okay, so ASearcher tackles these head-on with two key, pretty innovative contributions. The first one is a scalable, fully asynchronous RL training system.
Asynchronous, what does that mean here?
Well, in a standard batch generation RL system, if you have multiple AI agents learning at once, the whole batch, everyone, has to wait for the slowest one, the longest problem-solving attempt, to finish before the next round of training can even start.
So if one agent gets stuck on a really hard problem or goes down a long path.
Everyone else just sits there waiting. It's like a production line where one slow machine holds everything up. Super inefficient, especially for these deep multi-turn searches we need.
Right, a bottleneck. Makes sense.
Precisely. ASearcher's asynchronous system completely decouples that trajectory execution from the model updates. Think of it maybe like a busy research library. Every researcher is working independently. As soon as one finds a piece of info or finishes a step, they immediately share it back to the central knowledge base, or the librarian maybe.
Yeah.
They don't wait for anyone else.
I see. So multiple AI agents can be collecting these trajectories, these attempts, in parallel without waiting for each other.
That's it. It's a huge shift.
Yeah, it sounds like it. Because it means those really long search paths, the paper mentions potentially 40 or more tool calls, generating over 150,000 output tokens during training.
Which would absolutely cripple a standard system.
Right. Those don't slow down the entire process anymore. It really enables what they call long horizon search. Agents can explore much deeper, reason more thoroughly, without killing the training efficiency.
And it ensures near full resource utilization. You're using your computing power much more effectively. It turns that bottleneck into more of a multi-lane highway.
Okay, that's the system architecture. What's the second big contribution? You mentioned the data problem.
Right. The second contribution is equally revolutionary, I think. It's a prompt-based LLM agent that autonomously synthesizes high-quality, challenging question-answer pairs.
Wait, the AI generates its own training data?
Essentially, yes. It starts with a set of simpler seed questions, and then it iteratively modifies them, makes them progressively more complex, more difficult. It's kind of like an AI teaching itself by inventing harder homework problems.
An AI inventing its own curriculum. That's pretty meta. How does it make the questions harder?
It uses two main actions. One is called injection.
Injection.
Yeah, the agent enriches the context of the question. It inserts external facts related to entities within the original question. This makes the question much more intricate, more nuanced.
Can you give an example?
Sure. A simple question about, say, Michael P. Hine might get transformed by injecting facts into something like, regarding the Eggard College alumnus who served as the first county executive of Ulster County, New York, and who was also the first Democrat to serve in that office, what year was he appointed?
Ah, I see. So it adds layers of relevant but potentially distracting detail. It forces the answering AI to process more information and figure out what's actually key.
You got it. The other action is
Fuzzing.
fuzzing, like making it less clear.
Exactly. It blurs specific details in the question, increases uncertainty and difficulty. This forces the AI to infer more or search for broader contextual clues.
Very quiet.
Like replacing a specific year, 1934, with something vaguer like the early 1930s. Or changing a specific name, Catskill Mountain Railroad, to a more general description like a historic mountain railway.
Making the search much less direct requires more steps, more reasoning.
Absolutely. And what's really fascinating here is that these questions the AI invents for itself don't just get tossed into the training pile.
There's quality control.
Oh, yeah. They go through a rigorous multi-stage validation process. Checks for basic quality, measures the actual difficulty. It even assesses how well a smaller, focused reasoning model does without external tools to make sure the question genuinely needs search.
And ensures the answer is unique, findable, right? The paper says from an initial 14,000 seed QAs, this self-improvement loop generated over 134,000 high-quality samples.
Wow.
And get this, more than 25,000 of those specifically required external tools like web search to be solved. So it's really pushing the AI to learn those complex search skills.
It's like the AI is setting itself up for hard mode training to make sure it can handle the really tricky stuff we might ask later.
That's a great way to think about it.
Okay, to really bring this home, let's look at how this search intelligence plays out. The paper uses a complex query from the GAIA benchmark as a case study.
Right, GAIA is tough. It's designed to push agents with real-world, often ambiguous questions needing multiple steps, reasoning, fact-checking.
And this particular question involved finding a specific animal based on 2 conditions and like 4 initially unknown variables. A real puzzle.
Definitely a puzzle. So when existing online RL approaches tried it, the paper mentioned Search R132B.
How did it do?
Not well. It failed to effectively break down the complex query into smaller parts. It made ambiguous searches, got lost in irrelevant stuff.
Uh-oh. And even exhibited hallucinations. Basically, making things up. Unsupported conclusions not based on facts.
Yikes.
Yeah. It was limited to pretty basic search strategies, and that short tool use horizon we talked about, it hit its turn limit and either gave up or guessed badly.
So, overwhelmed by complexity leading to shallow search, unreliable answers. What about other approaches? Like prompt-based LLMs, the ones that can make more tool calls. They mentioned ASearcher-Web-QwQ.
Right. Searcher-One could do more extensive tool calls, retrieve quite a bit of relevant information, actually. But it often missed key details. It struggled to synthesize information from across different sources, and ultimately it still reached incorrect conclusions, even when it had technically found the right raw information somewhere in its search results.
So it could find the puzzle pieces, maybe, but couldn't quite put them together correctly, lacked that expert-level reasoning.
That's a good summary. It couldn't reason effectively from the retrieved content and its own search history. Okay, here's the moment of truth then. How did ASearcher-Web-QwQ, the agent built with these new asynchronous methods and the self-generated hard questions, how did it handle this same complex GAIA problem?
This is where you really see the difference. ASearcher-Web-QwQ demonstrated truly expert-level search strategies. Things that look much more like how a skilled human researcher might work.
Like what?
First, it decomposed the complex query into precise, focused sub-queries. Very methodical.
Okay.
Instead of just browsing lots of websites broadly, it honed in on the most relevant ones. And it efficiently summarized the key info from each site. Didn't just grab headline.
Processing the information properly.
Right. Then it explicitly listed and analyzed all the potential candidate answers it found, systematically ruling things out based on evidence.
Logical elimination.
Exactly. And when direct information wasn't immediately there, it skillfully inferred connections between different documents to piece together the answer, connecting the dots.
That's sophisticated.
It is. And critically, after finding a potential answer, I think it was mice in the example.
It didn't just stop there.
No. It spent further turns rigorously verifying its previous conclusions, cross-referencing against new data it found, before confidently reporting the final answer.
Double-checking its work.
Triple-checking, almost. It wasn't just pulling facts. It was building a strong, verifiable case for its answer.
So this means ASearcher-Web-QwQ exhibits these key behaviors we've been calling search intelligence.
Precisely. Things like uncertainty-aware reasoning, knowing when it's unsure, and needing to find more info.
Okay.
Precise key information extraction from noisy web content, filtering the signal from the noise.
Makes sense.
Cross-document inference, connecting those dots across different sources.
Right.
And grounded verification, always checking back against reliable data. It's systematic and it's reliable.
The results must show this difference then.
Oh, they do. The results in the paper are pretty compelling. Through this enhanced RL training, ASearcher-Web-QwQ achieved really substantial improvements.
How substantial?
Average gains of 46.7% on the challenging xBench benchmark and 20.8% on GAIA. Those are big jumps.
Wow, yeah. Compared to what?
It significantly surpassed existing open-source 32B agents. It hit scores of 42.1 on xBench and 52.8 on GAIA, which are strong scores for those benchmarks.
And it wasn't just about the overall score, right? You mentioned something about reliability.
Good point. It wasn't just raw scores. ASearcher-Web-QwQ also got significant gains in pass rate, especially on a subset called xBench Deep Search, a 17% improvement there.
Pass rate meaning how often it actually got the right answer.
Yes. It demonstrates the agent's ability to reliably find correct answers for these genuinely complex problems, not just, getting lucky sometimes. It means a much higher probability of success when you ask it something hard.
That reliability is key. Anything else stand out from the results?
One more interesting finding? Even ASearcher's smaller models, the 7B and 14B parameter ones,
Okay.
which were initially trained only with a local knowledge base, not live web access, they showed surprising generalizability when they were tested in realistic web-based search environments later.
So the skills transferred.
It seems so. It indicates that the sophisticated search strategies learned by ASearcher are robust and transferable. The core intelligence it develops can be applied even in new scenarios, making it highly versatile.
What a deep dive this has been. We've really explored how ASearcher tackles these fundamental problems in giving AI agents that expert-level search intelligence.
Yeah, from enabling those long, multi-turn explorations that mimic real human research.
To autonomously generating that really challenging high-quality training data that pushes the AI to constantly get better. This work really provides a clear and seemingly effective path forward for training more advanced agents. It's about building those foundational capabilities.
Letting AI truly understand, navigate, and synthesize information from the huge, messy web, moving beyond just keyword matching to, well, genuine comprehension.
That's the goal.
And with that, we leave you with something to consider. As AI agents become increasingly capable of discerning, verifying, and connecting complex information from the digital world, how might this change the very nature of what it means for us to be well-informed? Interesting question to ponder.